Okay, on this problem, we just need to prove this to be true. And so, what we're going to do first, so remember that this is going to be throughout the entire problem. I'm not going to write it until towards the end when I'm going to use it, just so I don't have to write as much. So if I have cosine of h minus 1 over h, I'm going to multiply this by cosine h plus 1. And I'm going to distribute that, so that's going to give me cosine squared h plus cosine h minus cosine h, so those are going to cancel, and then minus 1, so those cancel, and then on the bottom I just distribute the h to both of these, so actually we can just leave it separate, just like that. Okay, now if you remember the Pythagorean identity, sine squared x plus cosine squared x equals 1. So if we manipulate this to look like cosine squared x minus 1, I'm going to subtract the 1 on this side and subtract the sine onto the other side. So I'm going to replace all of this with negative sine squared h. And then we still have our bottom. Okay, now what we're going to do is we're going to split this into two different, here, so this is the limit as h approaches 0, and if we plug in a 0 at this point, we're going to have division by 0. But if we break this up into two different, we have sine h over h, so I took one of the sines from here and the h right there, multiplied by the limit as h approaches 0, and then we get negative sine h over cosine h plus 1. Okay. Now, I can't remember if I talked about this in a previous video or not, but sine x over x as x approaches 0 is equal to 1. Okay, and so this piece goes to 1. Over here, if we plug in a 0 to negative sign, we're going to get 0. And if we plug in a 0 to cosine, we're going to get a 1. So 1 plus 1 is 1. So we get 1 plus a 0 over 2, or times 0 over 2. And so 1 times 0 is equal to 0.